Hello friends, I welcome you all in the second video of the leveling. In last video of leveling, I have covered the detailed introduction of leveling. The detailed introduction is I have discussed about the aim and objectives of the leveling. Also have discussed about the applications of the leveling. I have covered various terms used in leveling, and I have also discussed about the instruments used in the leveling. So finally I have covered the overall brief introduction of the leveling in very proper way in my last video. If you haven't seen that video, I have incorporated the link of that video in the description below. You can refer it later on. So in this video I'm going to discuss about the remaining part of the leveling, and that's why I kept the name of this video as leveling part 2. So starting with the outline of this discussion, I'm going to discuss about the methods of leveling, and also I'm going to discuss about the classification of leveling as well. After discussing about these methods and classification, I'm going to start discussing about some various other technical terms which are again used in the leveling and which is helpful to you in understanding the example part or the application part of the leveling that I'll discuss with you. I'll give you idea about some form of relationship between those terms as well. And finally we'll start discussing about some important points that is necessary for staffmen and the level men to keep in their mind while doing this leveling work. And I'm also help you in understanding how to record these observations in actual leveling record book, right, so that you can understand the example part as well. And finally I'll discuss about the methods of leveling which are to be followed for the leveling work, and those methods are again to be discussed. I'm going to discuss in very detailed way with the examples, and I'll try to help you in understanding how to solve those examples on different methods. After that we'll try to see a variety of cases, as I have said in the beginning of my first video, that I'll try to touch upon the leveling on the continuous sloping ground, because it is somewhat different than when you are doing your leveling work on your regular terrain or a simple normal plain ground, right? So I'm going to discuss about that particular case as well, and I'll try to discuss one more example based on that particular topic. Then finally I'll try to come on the discussion of the correction, because whenever you take the readings or the observation in real field, there might be certain form of errors, and for compensating that error, to check that error, you need to apply certain corrections, because you cannot ensure your readings are as accurate or the completely correct one until and unless you haven't applied the correction over your observation. And I'm going to discuss about those corrections that are required to be applied in your observation when you are doing your leveling work. And also I'll try to touch upon a small example based on the correction, and then finally I'll try to discuss about the errors, which different forms of errors that we can have in our leveling work. And finally I'll try to end my discussion on leveling, and lastly I'll discuss about a small topic called contouring in context of leveling, because it is actually necessary to be understand, because it is very much important topic, and it is actually a vast topic, but I'm not going to discuss about it that much deep in with that topic, but I'll give you a brief introduction about the topic called contours, right? So without wasting time, let's get started in this video. So starting with the methods of the leveling, as you can see on the screen, generally you can say there are three principal methods used for determining the difference in elevations, right? Because we are now interested in determining the difference in elevation between some point. So if you see on the screen, there are three different methods I have mentioned on the screen, and namely they are direct leveling, which is also known as spirit leveling. The second one is your trigonometric leveling, which is also known as indirect leveling. Third one is your barometric leveling. Also I have said that there is another method which may be incorporated under this list. It is known as hypsometric leveling, though I have not incorporated here in this discussion, but still I'll give you a brief idea about that method as well. Right, so if you see these three methods, direct leveling, in trigonometric and barometric leveling, these methods are actually very detailed methods, and they are specifically discussed for the different cases. And as I said in the beginning of my first video, that this leveling chapter, this leveling topic, I'm going to discuss in context of the subject of basic of civil engineering, or basic civil engineering you can say, which is the first year subject. So that's why I'm not going to discuss about this trigonometric leveling and barometric leveling in that much detail. and I'll try to limit my discussion with direct leveling only. So I'll give you the classification of direct leveling. As you can see just below these three methods name I have listed, the classification of direct leveling is there, that I'll discuss after giving the brief introduction about these methods, right? So the first one, direct leveling, which is also known as spirit leveling. What is this method in fact? So look, it is that branch of leveling in which the vertical distance with respect to horizontal line, right? Horizontal line, you know now, the line which is now perpendicular to the direction of gravity, right? So the vertical distance is with respect to the horizontal line. It may be used to determine the relative difference in elevation between two adjacent points. So a horizontal plane of sight, right, the horizontal plane of sight, which may be definitely tangent to a level surface at any point, is readily established by means of the spirit level or the level tube, you can say, right? So in this method, spirit leveling, spirit level and a sighting device, which is nothing but a telescope, are combined, and vertical distances are measured by observing on graduated rods, or nothing but they are known as staffs on the points. So the method is also known as direct leveling, and it is the most precise method of determining elevations and the one most commonly used by engineers, right? So don't get confused. This is a simple method where you will make use of those leveling instruments we have discussed in the last video, dumpy level and the leveling staff. One can also use different other types of levels that I have listed on that during that discussion: Y level, reversible level, and automatic level, etc. So this is the most accurate and you can say most commonly adopted method by the engineers for your leveling work, right? And we are going to discuss about that method only in detail, right? Then the second one is your trigonometric leveling, which is also termed as your indirect leveling. So trigonometric leveling is not in fact a leveling, but trigonometric is a process, as you have studied in the mathematics. So trigonometric is the process of leveling in which the elevations of points are computed from the vertical angles and the horizontal distances measured in the field. So just as the length of any side in any triangle can be computed from proper trigonometric relation, right? So that's the simple method where what you will do, you will simply try to measure the vertical angle and you will try to measure the horizontal distance on the ground, and based on your trigonometric relationship you will try to compute the elevation of that point or the height of that point in the field, right? That's your trigonometric leveling. The third one is your barometric leveling, right? Now barometric leveling is a very special and unique type of leveling, you can say. So in this method what you have to do, generally in this method the altitude difference is determined by means of barometer. Altitude difference is nothing but is your height difference or elevation difference, right? So it is now here determined by means of barometer, and the barometer is a device which will give you the idea about the pressure differences, right? So what is the principle involved here in this method? It makes use of phenomena that difference in elevation between 2 points is proportional to the difference in atmospheric pressure at these points, right? So a barometer therefore may be used, and the readings observed at different points would yield a measure of the relative elevations of those points, right? So this is very again unique method, and it is now again make use of barometer. But however, if you see at a given point the atmospheric pressure does not remain constant in the course of the day and even in the course of an hour as well. So the method is therefore relatively inaccurate, and it is little used in surveying work except on reconnaissance or exploratory surveys, right? So that's why it is not of that much use, but still it is referred for certain form of survey work, right? Then as I mentioned that the fourth one we can include here in the list here is known as your hypsometric leveling. What is hypsometric leveling? The working of hypsometry for determining the elevation depends upon the fact that the temperature at which the water boils varies with the atmospheric pressure, right? So the boiling point of the water reduces at higher altitude, and thus knowing the boiling point of water, the atmospheric pressure can be calculated, and knowing the atmospheric pressure, the altitude or elevation can be determined. So it is somewhat similar to the barometric leveling, but the only difference being here is, here you are not going to make use of any instrument or something, but here you will try to identify the boiling point of the water, and that boiling point of the water is different at different altitudes, right? And this different altitude, the boiling point of the water is different, as it's due to the atmospheric pressure, and based on that the boiling point, you can compute the atmospheric pressure, and now based on atmospheric pressure you can now compute the elevation difference, as you have just as you can do in your barometric leveling. But your barometric leveling is somewhat very convenient over your hypsometric leveling, because it will give you direct these atmospheric pressure readings by use of that instrument called barometer, right? So that's how these different methods of levelings are there. And as I said, that I'm going to limit my discussion with the first one, that is your direct leveling or spheric leveling, right? So now we'll see the detailed classification of direct leveling methods one by one, and it is in fact very simple in understanding, right? So the classification of direct leveling methods is again very simple, and it is now available with so many other different forms of leveling. And it will generally start with the first one, which is termed as your simple leveling, right? So simple leveling is again, look, if you see on the screen, I have mentioned the important points to be remembered for this method, so that when you try to understand this method, you just try to remember this points, so that you can distinguish between these methods very easily, and it is very easy to understand to you, right? Though I'll give you a very good idea about this method one by one. Starting with the simple leveling. So this is the method which is used for determining the difference of elevations of 2 points which are now visible from a single position of the instrument. Mark this word, single position of the instrument, right? So that's why the level difference between 2 points is determined by setting the leveling instrument midway between the points. So that means, if you can see here on the screen in the figure, that the points you can see here is A and B, they are now visible from the single instrument station O. So this method is used when the difference of elevations of 2 points are less, or in other words, you can say when the 2 points are situated at not that much far distance away, and they are now visible from a single point or single instrument station, right? And that's your simple leveling. So then in that case, whatever leveling you will perform, that will termed as your simple leveling, right? But don't get confused. A simple leveling, that means you will make use of your dumpy level and your staff only. So it's a direct leveling method. So the procedure is going to remain same. However, the way of performing that particular method is going to differ based on this different classification. And this classification is available based on the factor that the cases or the variety, or you can say the situation may be different in your real field, right? Then the second method for this direct leveling is nothing but is termed as a differential leveling, which is also known as compound leveling and continuous leveling, right? So what is this method? This method is used when the 2 points whose difference of elevation is required are situated now quite apart, or when their difference of elevation is large, which is the reverse case of the first one, simple method or simple leveling, right? So this method is also known as I said, compound leveling and continuous leveling. And in this method, the level is set up at several suitable positions, and the staff readings are taken till the last points can be cited. So as you can see here on the screen, number 1, number 2, number 3, they are the different points where you are going to set your instruments again and again for to complete your leveling work, to reach your last point of the leveling, that is a B point, right? So the distance between A and B is now quite large. So definitely the difference in the elevation between these 2 points is going to be large, and that's why I have highlighted this point under this method, as it is used when difference of elevations of 2 points is large. Then this differential leveling is used, right? Then the third one is a fly leveling. Now, fly leveling is a method which is generally to be utilized in a case when, in simple, it is utilized when the differential leveling is done in order to connect a benchmark to the starting point of the alignment of any project, and that is called as fly leveling. That means whenever you perform your simple leveling, or rather you can say the second one, let's say you are performing your differential leveling, right? When there is a distance is quite large between 2 points, you are always keen or interested in checking whether your work is going in proper way or not, whether you want to check whether you are going in proper alignment, or along with the alignment, or not. So that's why you will always try to connect your readings with your benchmark, right? What you have considered as your reference. So the fly leveling is done to connect the benchmark to any intermediate point. It is not something that it is limited when you want to connect a starting point of the work to the benchmark. You can also connect, let's say here in this figure, you can connect this B point to the benchmark, you can also connect the C point to the benchmark, right? You can also connect your D point to the benchmark. But generally, when you want to connect your benchmark to the point of the alignment to check whether you are going with the proper alignment or not, then that particular form of leveling is termed as a fly leveling. And this is the case when you want to do the connection between a benchmark and the points, then this fly leveling has to be carried out, and that's the important point to be noted down here, right? So the level should be set up just midway between the 2 points, and the distances are taken as long as possible, as you can see here on the screen. This L1, L2, L3, L4 are nothing but they are the points where your instrument has been placed, and you have carried out your leveling work, and you have connected your benchmark with the starting point, and that part is termed as a fly leveling. That means this one, right? So that's your fly leveling. Then the next one here in direct leveling is termed as a profile leveling, and as I mentioned in the definition that you may have different two types of section available every time. One is known as a longitudinal section or L section, another is a cross section. So profile leveling is nothing but is your longitudinal section leveling, where you are interested in determining the longitudinal section of your work, right? And what is a longitudinal section? As you know, that when you are running along the length of these work, or you are running along the alignment of the work, then that is termed as your L section or longitudinal section you are trying to determine, right? So this is a type of differential leveling done for the purpose of determining the elevations of the ground surface along the alignment of, let's say, any project, for example, road, canal, railway, etc., right? And the profile leveling is also known as a longitudinal leveling, and the levels obtained in this profile leveling are used for plotting the alignment, or rather you can say for plotting the longitudinal section, and which is required for various purposes, such as to find out how much is the gradients, and you can then based on that you can determine what is the quantity for the cutting and what is the quantity for the filling, and that's how you can try to finish your work. So as you can see here in this figure, this first figure is indicating the positions of the staffs and the positions of the leveling instruments kept at the time of leveling, and as you are now moving along the alignment, the second figure is indicating the road, and these 1, 2, 3, 4 are the stop stations, and now you are moving along the alignment from point P to point T, right? So the important point to remember for this method, it is used to determine the elevations of ground surface along the alignment of road, railway, canal, etc. That means for any project, right? Now the next one is termed as your cross section leveling, right? So this is another similar to the profile leveling where now you are not interested in going along the alignment of the project, but now you are interested in determining the cross section of your project, right? So that's why you will move in perpendicular to the alignment, or you will move across the alignment, right? So what is this leveling, right? Cross section leveling. So cross section leveling is a leveling or you can say it is that type of differential leveling when it is done to determine the difference of elevations of the ground surface along the lines perpendicular to the alignment of the proposed project. It may be road, railway, canal, etc. So here, as you can see in this figure, right, these black cross lines, right, they are the cross sections, or they are the lines along with you are going to move for your leveling work, right? And not you are going to move along the alignment of this. So you will not going to move along the alignment, but instead you will try to move along these lines which are perpendicular to your alignment. That means you are moving across the alignment, then this is the direction. That's your cross section leveling, right? So the cross sections are generally taken at regular intervals. So as you can see here, they are taken as regular intervals. So this is nothing but the intervals, right? It may be 20 meter, it may be 40 meter along the alignment. And generally the profile leveling and the cross section levelings are done simultaneously, right? So the cross section are used for various purposes. Again, they are used such for determining the estimation of quantities, as I mentioned, for the profile leveling, right? And finding out the cross section of the area, how it is something the area, how much hilly area or how much slope area is there across the section. So the second figure you can see here, this is a typical example of your cross section leveling, right? So this is 1, 2, 3, 4, 5, 6. They are the points of where you have kept your simple, you can say, your staff, and you have computed the RLs of these points, and now you have plotted the profile, and your profile is looking like this. So you can now, when you want to make this profile a level one, right, a uniform one, so you can understand how much is to cut and what should be the quantity of your excavation and the filling, right? And that's how this cross section leveling is to be done, or is to be carried out, right? The next one is a check leveling. Now this check leveling is also somewhat, you can say, a bit similar to a fly leveling. This leveling is done for the purpose of checking of elevations which have already been obtained, right? What you have already been carried out, and you now interested in checking whether they are correct or not. So that particular leveling is termed as a check leveling. And the fly leveling, you can also say about fly leveling that it is done generally at the end of each day's work. So from the last station to the starting station for checking the day's work. So it is undertaken in order to check the accuracy of the day's work. So as you can see here in the screen, that A, B, C, D, E, they are the actual points for which you are doing your leveling work. And now at the end of your finishing point, that at point E, you will again commence your leveling work, and you will try to connect with your, or you will try to come to your starting point, and you will try to check whether the levels you have obtained, they were correct or not. That's known as your check leveling, which is similar to your fly leveling, right? Then the last one of this direct leveling method is termed as your reciprocal leveling. Now again, this is a special case of the leveling where you will not gonna see this form of leveling quite often, but this has to be carried out because these conditions are always there for different engineering projects, right? So this method of leveling is used for determining the difference of elevations of 2 points now which are situated on the opposite banks of the river. They are now situated on the opposite sides of the river, and it is not possible now for you to set up the instrument in the river bed, that is in the midway between the 2 points, and in this case reciprocal leveling is used. This method is again very simple. This is another typical example of a mathematic relationships only, right? So as you can see here on this figure, this point A and point B are now situated on the opposite banks of the river, and this in between this is your river is passing. So it is the cross section of the river, right? So now we are interested in determining the elevation difference between this point A and point B. So how it is to be done? So if you see in this figure number 1, that what you will do, you will try to place your instrument at this near to this point A, and you will try to take the reading at the point B, that is on the opposite side of the bank, and you will try to take the reading B1, and you will try to take the reading A1 as your instrument height or height of instrument, right? Then in the second case, you will try to put your instrument on the opposite side, that is at point B. You will determine the what is the height of instrument at B, and you will try to take the reading on the staff A, that is at point A, and then the difference in elevation will be computed by a simple relationship, or you can say by having the average relationship. That is nothing but your A1 minus B1 plus A2 minus B2 divided by 2. So that is nothing but is your you can say is your mean apparent difference of your level between your A and B, between your point A and B, right? So it is noted here that the error is going to be eliminated, and therefore the true difference will be equal to the mean apparent difference of the level between your A and B, and that is your reciprocal leveling, right? So this is again another method of this direct leveling only. So these were different methods of direct leveling, right? Now we're going to start discussing about some special terms and the abbreviations again used in your leveling, and that is again very much important to understand so that you can understand the example part very precisely, right? So I'll make it quick so that we can discuss more about the methods of leveling and the example, right? So the first one here in special term is your station. So in leveling, a station is the point where the staff is held and not the level is set up. Mind well and try to mark here that the station, when you used the word called station in your leveling topic, it is the point where the level rod or leveling staff is held and not where the dumpy level or the level is set up, right? So it is the point whose elevation is to be ascertained, or the point that is to be established at a given elevation. So that is known as your station. The next one is a backside. So backside is nothing but it is known as BS. The abbreviation used for backside is BS, as you can see here. And what is this backside? Generally, the backside is the site taken on this leveling staff held at a point of known elevation. to ascertain the amount by which the line of sight is above that point, and thus to obtain the height of the instrument. Now what does it mean, right? Let me elaborate this thing in a very simple language now. This is the first staff reading taken after setting up the instrument. That means after performing your adjustments of the levels, right? When your instrument is ready for taking observation, and that has to be carried out for every different points when you will change your position of your instrument from one point to another point, right? So the reading is always taken on the point of known elevation, and that known elevation, when it may be your benchmark, and definitely, and it may be your the changing point. What is change point? Where you have kept your instrument before changing before changing it to the new location, right? Because you have already calculated the reduced level for that previous point where you have kept your instrument, and now you are changing your position from that point to another point, right? So that point is now considered as a point of known elevation, right? So it is generally taken on the point of known elevation, that is benchmark or change point, right? And this is your backside or BS. Similar way, there is another sight, or the reading is known as your foresight, which is known as FS. And foresight is nothing but it is the last staff reading in any setup of the instrument, and it indicates the shifting of level. That means once you see the foresight reading in your record book, you should definitely understand that this was the last staff reading taken from that point, and now your instrument has changed its position. You change the position from that point to the another point, and then after setting your instrument to the new point, whatever the first reading you will going to take, that point or that reading is termed as a backside. So backside is your first reading every time, and your foresight is your last reading every time, right? And whatever different readings or some intermediate readings you will try to take between your backside and foresight, right? It may possible that when you keep your instrument on particular point or particular station, right, and you will try to observe you will try to take your readings at regular interval. So it may possible there are number of points you can cover from that particular instrument station, and that's how you can say there might be certain more number of readings between your backside and your foresight. So it is any other staff reading between your backside and foresight is termed as your intermediate sight or IS readings, right? So that's your IS reading. And the next one is a change point. This point indicates the shifting of the instrument. This change point is simply abbreviated as CP. It is also known as turning point in certain cases, right? And the next one is a height of instrument. Now, what is height of instrument? HI, right? So for any setup of the level, the height of instrument is the elevation of the plane of sight, that is elevation of the line of sight with respect to the assumed datum. What does it mean? Now the height of instrument, if you want to calculate, what you need to do, as you can see here in this figure, it is now very easy to understand from this figure all these definitions and the terms, right? Let's say if this is your first instrument station point and this is your second instrument station point here, right? So if you keep your instrument station point here and this is your benchmark, so what do you need to do? You need to do your first observation, and the first observation is always termed as your backside. So you will try to take your reading on the benchmark. You will keep your staff or leveling stuff on your benchmark, and you have already assumed that the RL of the benchmark is 100. When you keep your staff over here and the reading is coming as 5 feet, you are observing, as you can observe in your level. So the RL of this RL of or the height of instrument of this particular point 1 would be 100, which was already there for your benchmark, plus the 5 that you have measured or that you have observed in your leveling staff. So the height of instrument is always calculated, is generally it is the elevation of your line of sight. So this is your line of sight, and it is your elevation of the line of sight with respect to the assumed datum, that means this one. So this is your height of instrument, and height of instrument you mark here, it is the elevation between the line of sight and your datum, and it is does not mean that the height of telescope above the ground where the level is 10, that means this one. Somewhere try to understand this way, if this is the instrument and this is your point, so this is your, so this is not your height of instrument. Your height of instrument is this, which is nothing but is your elevation from your line of sight and the datum, right? So that's the thing you have to keep in your mind for height of instrument, right? So with this simple different technical terms, now we can understand the steps in leveling. Okay, now what is the steps in leveling? Generally, as we have discussed in case of the objectives of leveling, there are two steps in leveling. First one, to find by how much amount the line of sight is above the benchmark, that is this case, right? And second one, to ascertain by how much amount the next point is below or it may be above the line of sight, that is this case. That means this one, right? So what does it mean? Let's say a level is set up approximately between these 2 points. These points now are rod 1, rod 2, right? So rod 1 and rod 2 are the 2 points. Let's say these 2 points are given some name here. Let's say we'll give name as P, and let's say this is your point Q, right? What you need to do, your level is set up now between this point P and point Q, as you can see here in this figure, and the elevation of which is to be ascertained by your direct leveling, right? And the back, first what you will do, you will try to take your first reading, that is your back side, and you will try to take that reading on your keeping or holding or your leveling stuff at the benchmark. So you will try to get your height of instrument first. So that's why you will try to take your first reading HI, height of instrument, that is known elevation, that is a benchmark, plus your backside reading, right? Then you will try to turn your telescope to bring into a view of your point, you can say Q, right? Point Q. And what you will do, this point Q, when you will try to focus on your point Q, and the reading is taken on this point Q, and that reading is termed as a foresight, because if you see here, there are only 2 points available between from this particular instrument point, and there is no other point that you can bisect or you can try to sight from this particular point. So that's why this reading is termed as a foresight. Let's say if you understand, if it might be possible that you can try to find some other points available in between somewhere here, let's say P dash. So then in that case, let's say if you can say, if this is your P dash point here, what you can do, just a minute. So let's say if you have some other point in between your point Q and point this instrument, so then this reading, what you will try to observe for this P dash point is termed as your IS, and the reading for your point Q is termed as your Fs. So Fs, as you know, it is the last point or the last observation for that instrument location or instrument point, right? So you will try to turn your telescope, you will try to determine the RL of the stations, and the RL of the station is very simple. Again, you have determined the HI, that is the RL of HI is already done in your step 1, and what you will do, you will try to subtract your foresight reading. That means then what you are reading, you will try to observe here that this is your 6 feet. So you already know the RL of HI, how much it was, it is your 105, and now you subtract your 6 from 105, so the RL of this particular point Q would be 99, as you can see here in this figure, and it is very simple, easy to understand. So this is something very important thing. You see, your backside reading is always additive, right? And your foresight reading, it is always subtractive. However, you may find certain cases where you have to add your foresight reading in your RL of the previous point, right? But that's some specific cases. I'll give you idea at the end. Then what you need to do, again, if there is an intermediate point available between your last points, so RL of the station would be RL of HI minus intermediate side, right? And RL of HI would be RL of BM plus BS. That means I have elaborated this first step. And it may be change points, RL of change point if it is there. If you are going like this, let's say you have changed your instruments or location from point 1 to point 2, what you will do, you will try to find your height of instrument again for this point, that is this one. So what you will do, you will simply try to find by bisecting your telescope by keeping or holding your stuff on this point Q, you will try to observe that it is coming as 4.5. You have already computed the RL of this point 99, so you will add this backside reading in this 99, and you will get your new height of instrument for this point number 2, and then you will try to go for taking your further reading, that is your foresight, or it may be your intermediate side. So this is how these different things will work. I know it is still quite confusing, but it will be very clear when we'll try to discuss about the example part, right? So these were the different terms or special terms used in your leveling. Now the next topics are form of discussion. I'll try to summarize very quickly that there are certain important points that has to be followed by your levelman and the staffman. Levelman, that will try to be at the instrument location, and the staffman will try to keep that leveling stuff every time at different points. So there are 2 persons working for this particular exercise called leveling. So which are these important points that are required to be keep in mind by these level men and staff men. So I'll try to discuss about now points for leveling men, though I'm not going to discuss about all points, but some important points I will try to do. Okay, which form of different points are there which are to be followed by level men. Starting with, you can say, the first one would be the levels should be kept at a position so that number of readings can be taken. It is not something that you want to change your position of your level every time or so frequently, because it is tedious exercise and it may try to increase the chances of error in your survey work as well. So it is generally kept at a position so that the number of readings can be taken, and it should not be placed on the center line, right? That's the important point. Second point that is to be keep in mind by level men, that the height of instrument should not be too low or it should not be too high, right? Third may be temporary adjustments should be done properly. That is, you will try to check whether your level you have placed at the particular point, it is completely level or not, by checking your leveling tube or spirit level, you can say. Right. The next may be the eyepiece should be focused by holding a sheet of white paper in front of the telescope and make your crosshairs, that is your diaphragm, visible, distinct and clear. And the staff should be bisected by the pointing the telescope towards it, right? And that's how you need to check whether that your object class is also focused or not, right? And these are certain points, you can say, that has to be understood by your level men, those who are going to work at the level position. And similarly, there are certain points which are to be keep in mind by your staff man, right? So when it comes to staff man, he has to keep in mind about the points called, let's say, the staff should be held carefully while moving from one point or one station to another station. Then the second may be the staff should be held vertical on firm ground by holding it with both the arms, and while standing behind it or check bubble attached behind it to see its verticality. There are certain cases, or nowadays if you see whatever leveling staffs are there, they are available with the bubble tubes, and that bubble tubes are always checked to maintain the verticality of your leveling staff. The third may be the telescopic staff, if it is there, should be stretched and properly fixed on your springs catcher. Otherwise, there are chances that it may slip and it may try to form in terms of error. And the bottom of the staff, let's say, should be kept clean so that when you try to place on the station point, you can ensure its verticality. And the most important instruction given by the level men should be properly followed, right? So these are certain points which are required to be followed by the staff men, right? Now we'll see, or we'll discuss about the topic called the recording observation in the level book, because whenever you take this reading or observation, it has to be recorded properly to ensure that, or so that you can understand very properly that how they have written. So though I'm not going to read these observations for how to record those observations in leveling book, however you can pause the video and you can try to read this particular observations or these steps for recording your observation in a level book, but I'll try to make you understand while discussing about the example part only, right? But let's say I'll try to discuss about few here. The first one is the first reading of any setup is always recorded as BS, as we have just discussed in case of special terms. And second one is before shifting the instrument, last reading is recorded as FS, as well as that end of the survey work, last reading is recorded as FS. And third may be all reading taken between BS and FS in any setup are recorded as IS. So these are the things I have already discussed with you while discussing those special terms. So however, as I said, if you want to understand these points properly, you can pause the video and you can try to read this. It is self-explanatory, right? But these points are always necessary to understand so that you can understand how to record your observation in your record book, right? So now finally we'll jump to the computing your levels, how to compute your reduced level for different points by utilizing certain methods. And as I've said, there are certain methods, and there are generally two methods available in the leveling that one may utilize to compute the reduced levels, and I'll discuss these methods now very properly while discussing their example as well. Okay, so let's start discussing about this computing of reduced level with method 1. I think this particular snapshot I have incorporated in this first method is not clearly visible, but don't worry, I'll try to discuss properly by showing you the figure related to this method. So as you can see here on the screen, there are two methods available for computing your reduced levels in leveling. The first one is known as height of instrument method, HI, and the second one is known as rise and fall method. So let's understand the first method, which is nothing but your height of instrument method. And as I said, I'll try to discuss this method with this simple figure. I hope this figure is visible to you. Yeah. So let's start discussing about this first method now. Look, in this method, as its name suggests, the height of instrument is calculated for each setting of the instrument. It is to be done by simply by adding backside to the elevation or to the benchmark reading, right? So it has to be done for all particular you can say setting of the instrument where you are going to set your instrument, and that is very simple method. So let's understand from this particular figure only what it says, right? I'll try to discuss in step by step way. The first one says, if you see here in this figure, let's say this is the case available with us. Level 1 and level 2 are the two position. You will try to keep your dumpy level there, and these points, this 100, which is nothing but your benchmark, 1, 2, 3, 4, 5. These are the stations for which you are interested in computing their RLs, right? So do remember, they are known as stations because you are going to you're going to keep your staff, leveling staff, you're going to place your leveling staff over these points, and that's why they are these stations, and you're interested in determining the RLs of these points, right? That's why they are known as stations. Okay, so the first step would be this, in this method would be the height of instrument is calculated by adding your backside reading to the RL of the benchmark, that is at the first point. So let's say you place your level at this point, level 1. What you have done, you have simply observed your reading at this particular point at benchmark at 100. The reading is coming as 1.250, as you can see here in this figure. So the RL of the HIE will be, it should be added in your benchmark because BS is always added. So it would be 100 plus 1.250. So RL of the HIE is 101.25. Now you will turn your telescope, you will try to bisect your point 1, station 1, station 2, and then you will try to change the position, or this you will try to shift your instrument from the level 1 to level 2 position. So now you have bisected your station 1 and the reading is coming as 1.560. Now as I was trying to discuss with you during the special term discussion, if it is there, like before bisecting the last point for that instrument setup, if there are intermediate points are available in between, the observations are termed as your IS and not the FS, because FS is your last reading for any setup. So your station 1 is now giving you the reading of 1.560. So this is should be recorded as IS. Your station 2 is giving your reading as 1.750, and then again that is termed as your IS. Yet you have not reached to the last point. You can also bisect your this change point, and this may be the point from this last point from this instrument setup at level 1, and that reading is coming as 2.100. So now this reading is considered as your FS. So that's your next steps. Once it is done, this FS is the point, or FS is the reading. Now we are interested in computing RS. So how you will do? So as I have said, your IS and FS are always subtracted, right? They are always subtracted from your RL of HI. But sometimes, as I have said, that it may be added. How it may be added? You understand? Let's say if your backside, sometimes it may be applicable, or it is applicable for your benchmark as well. Look, we are saying here that your benchmark, your backside reading is always additive, and your IS and FS reading are always subtractive. But this case, it may be reversed. It may be depending on the situation. Let's imagine, let's say your benchmark is located on the roof of some ceiling, or roof of the tunnel, or roof of the ceiling of any room, you can say. So what you need to do with the instrument at the lower elevation, the backside must be subtracted from the elevation to get the height of the instrument. And similarly, if the foresight is taken on point which is higher than the instrument, the foresight must be added to the height of instrument to get the elevation of the point. So makes sense, right? It is not something, the solid rule that your backside is always added and your IS and FS should be always subtracted. It depends on the situation, but generally you will find this case. That's why I said in the beginning, your BS should be added and your IS and FS should be subtracted, right? So what you need to do to find out the RL of the station 1, you have to subtract your reading 1.560 from this RL of this station, that is 101.25, to get your RL of station 1. Similarly for RL of station 2 and RL of change point. Why this point is termed as your change point and not any other name of of station, because you're going to shift your instrument from after this point to another one, right? So after this you will try to place your instrument from level 1 position to level 2 position, and what you will do, you will try to find your height of instrument again for this new position of the instrument. And how you will do it? Again, following the fundamental, you will try to observe, you will try to keep your benchmark on the last point where you have observed the foresight reading, and you have already computed its RL by subtracting from the previous RL of HI, and you have computed the RL of this change point as 100, as you can see here on the screen. So now you are placing your instrument at level 2. You are observing your reading on the staff, and it is coming as 1.350. So the particular case, the RL of the HI would be equals to the RL of the change point is not written here. It is 2.100 reading of FS is written, but you can see here the change point RL is already computed, and it is coming as 99.150, which is here, this one, right? So the RL of change point is 99.150. So what would be the RL of your HI or new height of instrument? So it's a backside reading plus your RL of change points, right? So now the definition proves it proved right that the height of instrument is always generally, this backside reading is always generally taken on the point of known elevation. So when you are starting with your work, it will be your benchmark, and we are continuing in your work, it may be a change point, right? So that's how it is work. Again, you will try to turn your telescope, you will try to bisect your station 3, station 4 and station 5, and these IS and FS readings will be subtracted from your new RL of HI, that is 100.500, to get the RLs of this station 3, 4, 5, right? So now summarizing and following those instructions given how to record the observations in your recording leveling book, you can see here the first column is indicating stations. Then you will try to form columns for each reading, BS, IS, FS, HI. So there should not be any confusion between the readings to identify its type, right? So the first is benchmark, so that is termed as a BS reading, so it would be 1.250. For station 1 it is your IS, station 2 it is your IS, and for change point it is your FS. So you can see a 2.100 is written in FS. You can also see here that for change point the BS reading is also written, because it is generally used to compute the RL of HI for the new instrument, right? That's why this BS is also there for change point, and you will try to remark here in your remark column that this is your change point. You can indicate your change point, right? And you will see for change point there is an RL, at benchmark there is an RL. If you continue further, if there is any other change point after your station 5, you may find the another new RL of new HI available here, and in remark you will find it as your change point, right? So finally you need to check whether your observations what you have just carried out in your survey work by following this height of instrument method were correct or not. So you need to apply some check. So for this is a typical calculations. As you can see here, what I have just discussed with you by showing you that figure, it was very easy though, and you can finally say this calculation by slowing this video, by pausing this video. So now finally we need to apply the arithmetic check for this method to identify whether the observations what we have just carried out were correct or not. So the arithmetic check for this method is very simple. It is nothing but it is the difference between the algebraic sum of backsides and the algebraic sum of foresight, and it should be equals to the difference of your last RL minus first RL. So if you see this table, if you take the algebraic sum of backside, it is coming as 2.600, and algebraic sum of foresight is coming as 3.085, and if you take the difference of these two, it should be equals to the last RL minus first RL. So last RL and first RL is also there. Last RL is your 99.515 here, this one, and your first RL is nothing but is your benchmark reading, that is your 100. So when you try to put the values here, and if you see it is minus 0.485 and minus 0.485, that means your observations were okay, that they were correct and they are verified, right? So this check verifies the calculations of RLs of HI and that of the change point, and there is no check on the RLs of intermediate point. That's the disadvantage of this method. You can check your last RL and first RL, but there is no check available to verify your intermediate readings, right? Still, and that because of this disadvantage only, we can also go with the second method, which is nothing but your rise and fall method, which is available here. And again, this is another method of your computing your reduced levels, and again this is very simple method. So what is this method is all about? Let me give you now idea about this method. This method is again very similar to this first method, but again it is different. In this method, the height of instrument is not at all calculated, but the difference of level between consecutive points is found by comparing the staff readings on the 2 points for the same setting of the instruments. And the difference between the staff readings indicates whether it is rise or whether it is fall according as the staff reading at a point is smaller or greater than that at the preceding point, right? So how to understand this method step by step, let me give you an idea about from through this figure only. So I'll read it by step for you. So starting with this rise and fall method. Okay, so now what is this rise and fall method? So as I said, let's say this is the figure, this is the case available with us. This is the benchmark 100, as you can see here, and these are the two stations, these are the two positions where you're going to keep your instrument. This is, let's say this is a point 1 and let's say this is a point 2 here. What you'll do, you'll try to place your instrument, you'll do your own temporary adjustments, and you'll try to check whether your instrument is ready for observation. Once it is ready, you will first keep your staff on your benchmark. You will try to take a reading. So here it is coming as 0.675. You will add it in your BM and you will try to get your RL of HI. That we were doing in your first method, that is RL height of instrument method. But mind well, in this method we are not interested in calculating height of instrument at all. But however, those readings are noted, they are going to be recorded with their abbreviations only. First reading, it is always recorded as BS. Last reading is always recorded as FS for any setter, and intermediate readings are always recorded as your IS, right? So this is your first reading, BS 0.675. Then you will turn your telescope, you will bisect your station P, you will keep your leveling staff at station P, you will take the reading, and here reading is coming as 1.465. Then you will try to place a staff on the station Q, you will take your reading as 1.785, and this will be the last point that you can bisect from this point 1 by keeping your instrument at point 1. So this reading is recorded as FS and not the IS. So this is your FS 1.785. Then you will change your position, you will try to place your instrument from point 1 to point 2. Again, what you will do, after putting your instrument, you will try to observe your previous point, that is a point station Q. You will take that reading as 1.250 and you will be going to record that reading as BS only, right? Then you will turn your telescope again, you will bisect your station R by keeping your leveling staff at station R. You will observe the reading, here it is coming as 0.850, is recorded as IS, and for station S it is coming as 0.350 and it is recorded as FS because it is the last reading that you can bisect from this point 2, right? So now we are interested in identifying whether that was a rise or that was a fall. That means if you see this profile from when you are moving from one point station to another station, whether that difference between the readings are indicating there was a rise or there was a fall in the profile of the area, that we have to compute from these observations only. So now this is the table. We have incorporated all stations, that is BM, P, Q, RS, right? Mind well here. We haven't written change point here, but you will try to identify change point. I will try to write change point in remark column that you can see in last column. So first reading we have taken for this benchmark 0.675. Let me zoom out a bit so you can correlate with your figure, right? So it is written in your BS column. Second, it is written for station P, it is written in IS. For station Q, it is written in your FS, that is 1.785. right? But as you see, this is your Fs. That means this Fs is always indicating the shifting of instrument. So that's why after this instrument taking reading at Q, you will shift your instrument from point 1 to point 2, and after keeping your instrument at point 2, you will try to take reading to the previous point only where you have just carried out the Fs. That's why you will see for station Q there is another reading available or recorded here as BS, that is 1.250, and in remark column you will find it as change point. Okay, then for station R we have recorded reading in IS. For station S, we have recorded reading in FS. That's how we have recorded the reading. Now, the computation of rise and fall, how it is to be done. Now, you understand here in this table, okay? Now, you see the RLs, we are interested in computing for this all stations. So, we know the RL of benchmark, we have assumed as 100. Remark is saying this is your RL. right? Because you need some reference, because that's the main part of leveling. You need reference. This is the relative heights you are identifying, so you need something to identify the level or elevations of different stations. So that's why this 100 is always, it should be there, the benchmark RL should be always there with you. That's why we are assuming it. Okay, so now you see here, if you see the readings from 0.675 to 1.465, that means reading 1 to reading 2, irrespective of station, just focus over here for reading 0.675 to 1.465. Between these two reading, you see the relation, or rather you can see the variation of the reading. Your readings are your reading is increasing. What does it mean? If as I said, your leveling staffs are graduated from bottom to top, that means your 0 would come at the bottom and your maximum reading of the leveling staff will come at the top. So if your reading is more, that means he is indicating a fall. That means if you are observing through your telescope or through your level, if you are reading, let's say you are reading 4 for first station, and for next station you are reading, let's say you are reading 6, that means your leveling staff is going further below from the station 1. That's why you are reading more value here. That's why this 1.465 from this 0.675 is indicating fall, and fall is always considered as negative. So that's why if you can see, you can take the difference of 0.675 and 1.465, and it is coming as 0.9790. This is this one, and that is written under this column of fall. So to compute the RL for station, the fall is always subtracted from the previous RL and your rise is always added, right? So this is the fundamental rule you have to keep in your mind. So you will see your RL of the station P would be 100 minus 0.790, so it will be equals to 99.210. Right, this is very simple. Similarly, when you move from, let's say for station Q, if we talk, so station Q, when you are moving from reading 2 to reading 3, that means when you are, first we moved like this, now we are moving from this 1.465 to 1.250. So I'm sorry, we are moving like this 1.465 to 1.785. So now 1.465 to 1.785, that means again your reading is increasing, that means it is indicating fall. The difference between these two, 1.465 and 1.785, is 0.320. That's why it has written here in fall column, and it has to be subtracted from your previous RL, that is the RL of station P. So you will get the RL of station Q as 98.890. And again you see this is a change point, that means now your reading, after this reading 3, you moved from reading 3 to reading 4, that is from 1.785 to 1.250. Now here what is happening, your reading is decreasing, that's why it is indicating a fall. It is indicating a fall. But generally if you see here, with respect to this point Q, with respect to this R, once we have computed the RL for Q, we are now interested that directly what you need to do, we are now moving from this 1.250 to 0.850. So that means we have moved from 0.675 to 1.465, from reading 1 to reading 2 for in context of point P or station P. Then for station Q, we moved from reading 2 to reading 3, that is 1.465, 1.785. Now it is change point, we have changed the location. So the first reading for the station Q would be now 1.25. So you need to start your exercise again. So first, in regard of station R, you are moving from 1.250 to 0.850 and not from 1.785 to 1.250. Mark well here because it's a change point. So 1.250 to 0.850, that means it is reading is decreasing, it is indicating rise. So the difference between these two would be 0.400, so it is written over here in rise column, and it has to be added in your previous RL to get the RL of station R. That's why it is 99.290. Right, and finally in context of station S, you are moving from 0.850 to this value 0.350, and that's why it is again now indicating decrease in reading, so it is indicating rise again. It has to be added in your previous RL, that is 99.290, to get your RL of station S, and it is coming as 99.790. So this is your rise and fall method. So as I have said, here we are not interested in calculating the height of instrument, but rather we will simply will try to identify whether it was rise or fall based on the comparison of these readings only, right? And it is quite easier, quite simple as well. However, it is necessary to it is necessary to focus on the readings, and it is always necessary to identify your readings properly, and there should not be any error, there should not be any mistake in recording this reading as BS, IS or FS. Otherwise it may terms in your error, it may terms in your inappropriate calculations, right? So this is the just calculations of RLs of differentiation PQRS, just what I have discussed with you in that table. So again we need to apply arithmetic check for this method as well. And as like the first method, the arithmetic check here for this method is somewhat, you can say, summation BS minus summation FS. It should be equals to summation rise minus summation fall, and it should be equals to summation of difference of last RL minus first RL. So now you see here we have one more check than the height of instrument, because in height of instrument we were having only two checks. Summation BS minus summation FS should be equals to last RL minus first RL, and here we have additional one more, that is summation rise minus summation fall. So that means when you do it, and if you try to see the reduction of complete check, you can say on intermediate side is also provided by having this third check, that is summation rise minus summation fall. And this, and something you can say, this is the advantageous thing over your height of instrument method. But however, there is always matter of choice whether you want to go with your HI method and rise and fall method. That's why it is necessary now to discuss the difference between these two methods quickly, so that you can understand when to choose these methods for your leveling work. So when you compare these two methods, it has been observed that your HI method is more rapid and it saves times and labor, and your rise and fall method is laborious, involving several calculations, because as we have just discussed in your rise and fall method, that you need to identify the rise, whether it was rise, whether it was fall. So you need to carry out so many calculations, so it is laborious work, right? So that's in the first point you can say your HI method is more advantageous one. Second point says that there is no check on RLs of intermediate station. However, it is available in rise and fall method by that summation rise minus summation fall. So that's the advantageous thing of your rise and fall method over your HI method in second point. Third one says that errors in intermediate RLs cannot be detected, that is in HI method, and errors in intermediate RLs can be detected in rise and fall method. Again, it is the advantages over your HI method. The fourth top point, it says that there are two checks on the calculations of RLs, and in this rise and fall you have three checks on the calculations of RL. Again, it is advantageous over your HI method. And the fifth point says that this method is more suitable for profile leveling, whereas your rise and fall method is more suitable for your fly leveling. So this is a quick comparison between these two methods. So now you understand when to choose different methods and when to do different form of calculations, right? So I think this is all about this methods of this leveling. And finally, what we have to understand here is about now the calculations. So we'll try to see a typical example of this methods now, to understand again about this method, right? So we'll try to see this typical example based on HI method and the rise and fall methods now. So as you can see, I have incorporated one example here. So if you see here, this is your example data which has been mentioned here. It is quite readable. So I'm not going to read this example, but I'll try to discuss this example in terms of its solution. Okay. So now you see here we have given a data, and we have to compute the reduced levels for different points, and we have to apply the checks as well, just to identify whether our computed RLs were correct or not. Okay, so we have simply given these readings as 0.350, 0.580 and so on up to 0.630, as you can see here in this data, right? So before making use of these methods HI and rise and fall, we have to record this observation, or rather we have to identify this observation, whether it is indicating BS or whether it is IS and so on, right? So let's start simplifying these readings for the calculations. You see here, first one, the 0.350 is the first reading, and as you move from 0.350 to 0.630, that 0.630 is a 12th reading. So you have total 12 readings available with you. Okay. So now the first reading is always, we know that it is recorded as BS, and the last reading is always recorded as FS. So it is very clear that your 0.350 and your 0.630 is your BS and FS, right? Then you see here your instrument, we have given in data that the instrument was changed, or instrument was shifted after 3rd, 7th and 10th reading, as here this one. The instrument is shifted after 3rd, 7th and 10th reading. So we have also given this thing, because this should be known to you, because from this observation only you can't predict whether what was your change point, or when you have changed the positions of your instrument from one point to another point, right? So it should be known to you. So here if you see that these are the 3rd, 7th and 10th readings, your instrument was shifted. So the 3rd reading is nothing but is the 0.645. That means you can say this 0.645 is your FS reading, because once you place your instrument, you observed your BS at 0.350, you will take your reading at 0.50 as IS, and 0.645 it should be your FS, because you are changing your instrument after 3rd station. That's why this 0.645 is recorded as FS. Similarly, what you will notice, your 1.850, then the reading 4 is turned as your, that is this one is always recorded as your BS, because after shifting your instrument, whatever reading you will going to observe for your new instrument location is termed as your backside reading, BS reading. So this is your BS, then 1.935, 2.450 until the 7th reading, and the 7th reading is nothing but is your 1.750. This 1.935 and 2.450 is there your IS intermediate sites, and 1.750 is recorded as FS. Why it is so? Because it's your 7th reading. We have already given that you are also changing your instrument's location from 7th readings after your 7th reading. So 1.750 is your FS, right? Then again you will observe that 0.360 automatically it will be recorded as your BS reading, because it will be your new reading after your new instrument location after your 7th point. And then finally your 0.720 is recorded as your IS, 1.200 is also going to be recorded as your IS, and finally if you see here, until you are going to finally reach towards your reading number 10th, and 10th reading is nothing but is your 1.200, this one. So 0.720 is IS and 1.200, that means you are changing your position of the instrument from after 10th reading, that means it is your FS, that 1.200 is FS. And definitely if it is your FS, then the very next reading would be your BS. And finally 0.630 we have already concluded in the first step that it is your FS. It is your last reading of the survivor, right? So after this analysis, now we have recorded those readings for our calculations very properly in this table. So this first column is station, then we have already given chain edges for this station, respective chain edges, right? But this is just for your understanding, right? At what interval you have considered the point to compute its RLs, right? So this is for your information, that is the second column. Then the column BS, IS, FS and HI. So this is your HI method, that's why this column HI is there. And now we'll try to see how to do it. So we have recorded these readings as per the given data, BS, IS and FS, and finally it is there with you. What you have to do? Now start computing the RL. So the first station is nothing but is your BM. We have to consider your first reading as your benchmark, and because we have already, if we talk about first reading, it has been already taken on the point of known elevation, and for the starting of survey it should be the benchmark, and in data we have given as your benchmark is given as 50.000, right? So the station for station 1, your RL is already given to you, which is your 50.000, and you will try to write in remark that it was your benchmark. So you have for benchmark or for station 1, we can calculate the height of instrument. How it has to be done? You need to add BS in your benchmark reading. So the reading was 0.350, it should be added in your 50, so your HI would be 50.350, right? Then for station number 2, you have recorded the observation as 0.580, and you need to compute the RL. Mind well, for computing RL, how you will do it? You will try to subtract your IS reading, that is 0.580, from previous RL. And what should be your previous RL? Your previous RL is nothing but is your RL of HI. That means you will subtract your 0.580 from this height of instrument and not from the benchmark, right? You will try to follow the points. That means you will always try to compute the RL for your next station from the by having the reference of previous point station RL. That's how it is to be done, right? So if you subtract it, it is going to come as 49.770. Then for station 3, your BS reading was for FS reading is there 0.645. So FS reading is again going to be subtracted because it's your FS from your previous RL. So if you subtract your 0.645, but it should be subtracted from RL of HI, mind well, RL of HI and not from the RL of last station. So RL of HI is to be kept in your mind. So if you subtract your 0.645 from this 50.350, then it is going to become as 49.705. But as we know, after your reading 3, we have to change the position, so it is going to be indicated as change point 1. And for the same, you will going to take the another observation from new instrument location, and that is coming as 1.850. Should be recorded for station 3 and not for station 4. Okay, so this is your BS. So for if it is BS is there, you will going to calculate your new height of instrument, and your height of instrument would be equals to your BS minus your BS plus the RL of that station. So what was the RL of the station number 3? RL of the station was 49.705 and your BS is coming as 1.850. So if you add 49.705 plus 1.850, you will going to get this 51.355. So now you have another RL of HI available with you. Okay, so what you have to do, finally move further. You have to compute the RL of next station, that is station number 4. So you have this IS reading, that is 1.935. It should be subtracted from your new HI now, that is 51.355. So it would be 49.620, that is here, you can see here. Then you have you can compute the RL for station number 5. You have the IS available as 2.450. It should be subtracted from your RL of new instrument RL height, that is RL of HI, that is 51.355 again. So 51.355 minus 2.450, if you subtract it, you will get as 49.105. Once it is there, you will finally compute the RL for station number 6, and this is the location after which you are going to change the location of the instrument. So that's why this reading is not IS, that is FS 1.750, and it should be subtracted from this 51.355. If you do that, you're going to get your reading as the RL, that's 49.805. So RL of station number 6 is also there with you. But as we are shifting our instrument from after this station, this it is indicating as change point 2. And once it is there, you will try to observe the first reading from new location to that station number 6 only. That's why it is recorded as the BS. So once you have BS, your new HI is to be calculated. So this BS 0.360 should be added in your RL of the station number 6, that is 49.805. So it would be going to come as 50.165. So for RL of station 7, that is your IS reading 0.720, it should be subtracted from this new RL of HI from new position, that is 50.165. That would be equals to 49.445. And RL of station 8, because this after this again also you are changing your position of instrument. So this is your FS reading. So 1.200, once it is subtracted from 50.165, it would be equals to 48.965. So that is the RL of your station number 8. And RL of station number 8, if it is done, then finally you are shifting your instrument to the new location, and you are now marking over here as change point 3, and you are observing the backside reading from a new location for station 8 only, which is 0.920. And once it is there, you will try to compute new height of instrument, and that would be equals to this BS reading to this RL of this point. So it would be equals to 49.885. And that's how, if this is there, the last reading is your FS 0.630. If it should be subtracted from 49.885 to get your RL of the last station, that is station number 9. So finally it is your 49.255. Right. So this is how it is to be done. And finally you will see, now one will wonder that we have 12 reading. However, in station you will see there are only 9 stations we have identified. Why? Because if you see, for backside reading, we have taken that backside reading on that previous point only. So that's why this, you will see there are only 9 stations, but readings, if we try to calculate, we try to count for BS, IS, FS, it would be equals to 12. Right. So finally it is time to apply the check. We will get summation BS and summation FS. So summation BS and summation FS is now calculated here. It is 3.480 and 4.225. Take the difference of it, equate it with your last RL and first RL. So what is your last RL? Is your 49.255, and your first RL is nothing but is your benchmark 50. If you take the difference of these two, it is coming as equals to your summation BS minus summation information of it. That means our computation of reduced levels for all the stations are correct, and that's the necessary check. If it is not coming equal, that means we made certain mistakes and we have to check our calculations again from the first station to the last station, right? So this was your height of instrument method. Now the second method, this is your rise and fall method. So again, this is a method where we are not interested in calculating height of instrument, but we will identify whether it was rise and fall by comparing the two different staff readings. So simply we have to copy the same readings for your station, chain, and BS, IS, FS from the above table only. Instead of HI, now you see here there is another two column, rise and fall. Rise is indicated as plus and fall is indicated as minus, right, to compute your RL. So finally, let's get started. We have RL of first station, that is benchmark 50, which is given in data. We have the BS reading for station 1 from the first instrument point or first instrument location, right, or first instrument setup. It is 0.350. So again, what we were doing in HI, 50 plus 0.350 will get the height of instrument for the instrument location 1, but that we are not going to do here because it's a rise and fall method. So we'll simply proceed. So finally, we know what we need to do. For station 2, we are moving from 0.350 to 0.580. That means your reading is increasing. As your reading is increasing, it is indicating what? Fall. The difference of these two would be 0.230. So that's why it is written over here in your fall column. And fall is always subtracted from your previous RL. So that means 50 minus 0.230, it will give you 49.770, right? Then for station number 3, we are moving from 0.580 reading to 0.645 reading. Again, it is increasing. That means it is indicating fall, and that the difference is 0.065. We have written in fall column. It has to be subtracted now, but again, this is the trick. This is the main point, that this 0.065, that fall reading, should be subtracted from this one and not from the RL, or not from these benchmark every time. While in HI, the subtraction has to be carried out from the height of instrument. Until and unless you are not having new height of instrument, you have to keep subtracting your IS and FS reading from that particular height of instrument reading only. But here you need to follow the sequence and you need to subtract your readings from your previous RL of the station. That means we are going to subtract it from 49.770, and 49.770, if we do that, we will get 49.705 here, right? So now this is a change point, so that's why we have BS reading available as 1.850. so that's why it is indicated as CP1 in your remark column. And what we have to do now, simply for station number 4, we are moving from 1.850 to 1.935. That means your reading is further increasing, so it is indicating fall. The difference is 0.085. It has to be subtracted from your previous RL, and if you do that, 49.705 minus 0.085, you will get 49.620. Right, moving further, you are moving from 1.935 to 2.450, and that is for station number 5. So it is again your reading is increasing, so it is indicating fall, and the difference is written over here, 0.515. Subtract it from your previous error, that is 49.620, you will get 49.105. Right, now further we are moving from 2.450 and we are having reading as 1.750. so now your reading is decreasing. So if it is decreasing, that's why we have written under this column fall, as you can see, column rise, as you can see here, that is 0.700. and if it is rise, it has to be added in your previous error, so that 0.700 is now added in a 49.105. that's why you are getting your RL of station number 6 as 49.805, and this is a change point. That's why you will mark it CP2, and you have this BS reading available here. Right, so for station number 7, you are moving like this, from 0.360 to 0.720. your reading is further now increasing, so it is indicating fall. It is written in fall column, and fall is subtracted from previous RL, so 49.805 minus 0.3060, it will going to give you 49.445. right, again you are moving from 0.720 to 1.200, so your reading is further increasing. It is indicating fall again. It is written in fall, 0.480. subtract it from 49.445, you are going to get as 48.965, and this is CP3, change point 3, so there has to be BS, and it is that line 0.920. so finally for station number 9, you are moving from 0.920 to 0.630. that means the reading is further decreasing, not increasing. So the reading is increasing, reading is decreasing, that's why it is indicating your rise, and it is written under your rise column, that is 0.290, and rise is to be added in your previous RL, so it is 48.965 plus 0.290, and you will get 49.255. That's how the RL of different stations are computed using rise and fall method. So finally, applying check, summation BS, summation FS, summation rise, summation fall, last RL minus first RL. If you do all that, your readings are coming all equal, your checks are coming all equal. That means whatever calculations of RLs we have carried out, they are correct, or they are proper one, right? So that was the example, a very simple example yet useful example to understand these methods, that is height of instrument method and your rise and fall method, right? So I hope these methods are now clear to you, and now you can understand about this method properly. Okay, so now finally what I'm going to discuss with you regarding the remaining topic. So the topic is leveling on continuously sloping ground. Now this is the topic, it is something you can say it is somewhat similar to what we have just discussed for height and instrument and rise and fall method. Yet we have to understand this topic because it's a continuous sloping ground. That means here you have to identify your shifting of instrument by yourself by observing readings only, and that we can do it easily. We can do it as just we did for rise and fall. How it is done? So let me talk about this method first of all. When the staff readings are taken on continuously sloping ground, the maximum staff reading can be staff height, right? And the staff readings will gradually increase initially, but then they'll suddenly decrease. How? What does it mean? You see here, let's say if this figure, this is your instrument station location, let's say this is your 1, station 1, and instrument location point 2. You will put your staff, you will keep your staff at station 1, then you will keep your staff at 2. Now as this is a continuously sloping ground, your staff reading will goes on increasing from 1 to station 2, then 2 to change point, and finally what will happen once it is a change point, it will goes on increasing until it reaches to the maximum, and finally you will see the sudden decrease in the reading, right? They will decrease, and you will see that sudden decrease is indicating the shifting of instruments. So as you shift your instrument from 1 to 2, your reading will be lesser, or it will try to give you a sudden decrease. So we are talking about this sudden decrease, right? So that's how we can identify that after this reading, that means this is your indicating your maximum reading, and now very next reading is indicating very less reading. That means after this particular point, that means this one, let's say this is given as point Q, your instrument is shifted from this point 1 to point 2, and that's how this leveling on continuously sloping ground will work. So this is again very simple concept, and this is same as what we have discussed for height of instrument rise and fall method. For your understanding, I have simply incorporated one more example based on this method, that how to identify these change point from the instruments only, right? So this particular data is available here. You can pause the video, you can try to read the example, and I'm scrolling slowly so that you can understand, or you can try to see this example calculations. So this is again to be calculated by using height of instrument as well as for using rise and fall method. We can do it by using either of these two methods. So this is the first of all recording the readings for BS, IS, FS, then height of instrument column, RL for different station, and remark to identify whether it was change point or not, right? So you can finally pause the video and you can try to calculate this example by your own. Finally, this is the arithmetic check, okay, and this is also coming okay, and this is your rise and fall method. This is the table for rise and fall method, right? You can pause it here, you can try to calculate it by your own, and finally verify it with the answer in my video to understand this concept of rise and fall and HI method, right? So that's all about your different methods in your leveling. Now we are moving towards the end, and this end, when we are moving towards the end, as I said, I'm going to discuss about the corrections and the errors, right? So let me talk about this correction and errors very quickly because they are very simple to understand. There are two types of corrections we can apply in leveling. That corrections are known as curvature correction, or it may be refraction correction, right? So what is curvature correction in fact? So you see, when it is long sides, when your station is quite at far distance from your instrument location, then the curvature of the earth affects the staff readings, and the line of sight is horizontal but the level line is curved and the parallel to the mean spheroidal surface of the earth. What does it mean? Your line of sight, if you see here, is generally, is we can say here, in the figure if you see, this A dash is your instrument where you were kept, and finally you see when your staff is kept at this location, that means that here your level line is this, which is finally going to give you reading at C, but your horizontal line will try to intersect at point B. So the difference between these two is termed as a curvature correction. So the vertical distance between the line of sight and the level line at a particular place is called curvature correction. And the effect of curvature is to cause the objects sighted to appear lower than they really are. What does it mean? Let's say you imagine if your earth is not curved, and if you imagine the earth is flat, you could have get your reading at B and not at C. But as your surface of the earth is spheroidal one, your level line will be the parallel to the spheroidal surface, and you will get your reading at C and not at B. That's why it will try to give you somewhat lesser reading what it is actually is available, right? From what you can get from the horizontal line of sight. So then the difference between these two is known as your curvature correction, right? So generally it is applied when the distance between your instrument and your station is quite large, right? So a very small derivation of the formula is there for calculating the curvature correction, and it is derived by this. Let's consider this is your earth, and let's say if this is the C is the center of the earth, then this R is nothing but is indicating the radius, this D and D dash line is indicating the diameter, and finally you see here your horizontal line is A and B, which is connecting A and B, okay, and your level line is A and D, which is parallel to the spheroidal surface of the earth, right? So what you have to do, from the right angle triangle, that is ABC, the BC square would be equals to AC square plus AB square here. And if you do that, you can see this BC is nothing but is your radius of the earth, plus you can say is a curvature correction, right? And that's how it is R plus CC square, which is written over here BC square. Your AC square is your radius of the earth, that's why it is R square, okay? And you can say your AB is nothing but is your D square. So because AB we have given is your D is horizontal distance. This is not the diameter we are saying. Diameter is this one, but we are saying this distance between this point A and B, and it is given somewhat as, let's say, D. That what we are taking as in our calculation D. So this AB square is D square. Once you put all this abbreviation in this part, try to simplify it, so you will get your D square is equals to CC into 2R, that is this part. So CC square is neglected here, as it is very small in comparison to the diameter of the earth, right? So that's why CC square in this formula is neglected, and you will get final form as D square is equals to 2R into CC, right? So finally your curvature correction CC is equals to D square upon 2R, and it would be in kilometers, right? So if you try to substitute, or if you try to calculate in meters, so the formula would be slightly different. We can also try to put the value of radius of the earth as we already know. So it would be D square into 1000 divided by 2R, that is nothing but the diameter, so it is 12742 kilometer, and to eliminate kilometer we have multiplied 1000 here in numerator. So finally you will get the value or form as 0.0785 D square in meter. And mind well, curvature correction is always negative and not the positive one, where this D is the distance in kilometers. So now what you need to do to simply apply the curvature correction, you want to measure the distance, or you should measure the distance between your instrument to your station, which is now available at far distance, right? That's how the curvature correction is to be calculated. It is always subtracting. So true staff reading would be equals to observed staff reading minus your curvature correction, right, as you can see here. So that's how this curvature correction is come into the picture. Next is refraction correction. Now this is refraction correction is also a natural one. What will happen in this case? So the rays of lights pass through the layers of air of different densities, and it refract, or rather you can say it try to bend down, and the effect of this refraction is to make the objects appear higher than they really are, because the effect would be in opposite way. Let's say if your rays are bending down, your object will try to appear somewhat higher than they really are. So refraction correction varies considerably with climatic condition, right? And however, you can say on an average, it is the formula is already given to us. It is taken as 1/7 into 0.0785 D square. So it would be equal to 0.0112 D square in meter. And mind well, as your objects are appearing somewhat higher than they really are, your readings, this correction is to be add in it. Okay, so your true staff reading should be observed staff reading plus refraction correction. So mind well, your refraction correction is always additive and your curvature correction is always negative, right? So there is one small example I have incorporated in this discussion in my notes. You can see here a snap of that example. Find the correction for curvature and the distance 800 meter and 2.5 kilometers. So you make a use of those formulas available in our discussion, and finally you can get this correction. And this correction, when it is subtracted or added from your observed staff reading, you will get the true staff reading. Okay. So that's all about the corrections, and finally it's now time to discuss the last topic of the discussion, and this is nothing but the errors in, you can say, in your leveling. So when we talk about the errors, or when we talk about the errors in any case, the errors may be of generally of either of having these three different sources, as you can see here on the screen. The first one may be personal errors, the second is instrumental errors, and the third is your errors due to natural causes. So I'm not going to discuss the all possible form of personal, natural and instrumental errors, but I'll try to discuss few important of all of these errors. So when we talk about personal errors, it may be due to, let's say your instrument may not be leveled perfectly. If you have not followed the temporary adjustment properly and your level tube is not in center, and if you try to observe your reading, then your readings are, you can say, they are available with error, right? That is due to your personal error, right? Second, maybe you're focusing on object class and eyepiece is not done properly, and it may say, you can say, your position of the staff may be disturbed at the change point, and also you can say the reading may be taken either upper at lower stadia hair by mistake instead of at the middle stadia hair in diaphragm, central hair, right? So this may be certain, these are the certain personal errors you may find so many times during your leveling work, and you have to make sure that these errors should not be there in your leveling work, right? The instrumental errors are due to some faulty instruments, you can say. Let's say you can say that your dumpy level is quite damaged, or you can say the line of collimation is not exactly parallel to the horizontal line. The center of the eyepiece and the center of the object class, if you try to connect, it is not exactly, you can say, parallel to the horizontal line, and that may happen due to the faulty instrument, right? Let's say the graduation on the leveling staff may not be perfect, it has been now deteriorated with the use. So there are certain form of errors you are going to encounter in your survey work due to this faulty instrument. That comes under your second form of error, that is instrumental errors. And the third is your errors due to natural causes. It is something very easy to understand. Let's say, as we have just discussed in the case of correction, the curvature of the earth may affect the staff reading when the distance of sight is too long. Similarly, the effect of refraction may cause a wrong staff reading when it is taken, and there are some errors in staff readings and due to high wind velocity and due to some climatic conditions as well. So this falls under the third form of error, that is your errors due to natural causes, right? So these are the errors one has to take care while doing your leveling work, and you can eliminate these errors by checking your instrument quality before you're starting your work, by make sure the preciseness and the ability of the staffman and the levelman for your work, right? And these natural conditions can be well eliminated by applying those corrections, curvature correction and refraction correction, right? So that's all about the leveling. Now here I can conclude that we have discussed all possible important topics of the leveling. And now finally, as I've said, as a bonus or simply a small topic of contours, I'll discuss with you very quickly. Now contour, as we know very well, that one of the applications or the objectives of leveling says that to prepare topographical map or contour map. So what is this contour now, right? So let me give you an idea how it will look like. Now focus here on this figure, as you can see on the screen. So I'm going to discuss this contour through this figure only. As you can see here, this part is indicating the plan, and this is the actual geometry or actual topography of any area, right? So what is this contour line? First of all, let me give you an idea about it. Look, contour line, it is something you say it's an imaginary line. Mind well, it's an imaginary line. It's not any real line that you can find physically available on field. It's an imaginary line passing through the points of equal RLs or equal reduced levels. What does it mean? in any terrain or in any topography or in any area, you may find that you can find so many points of same RLs available in that area. Let's say if you imagine a plain ground or if you imagine a uniform ground, you may find most of the points are having more or less same reduced levels. So if you try to connect the points of same elevations or points of same RLs, then that particular line is termed as your contour line. Right. So as you can see here in this particular figure, let's say it is written as 1100, 1200, 1300 and 1400. So that means this 1100 line is indicating that it is joining the points of 1100 elevation. Similarly, this 1200 is indicating that the points are now having the points on this line are now having same elevation as 1200. Right. So this is how this contour line has to be prepared. Look, the contour line may also be defined as the intersection of level surface with the surface of earth, you can say, but it is somewhat difficult to understand. That's why you better remember in this way. It's an imaginary line joining the points of same elevation or same RS, right? So the contour lines on a plan illustrate the topography of the area. That means if you have this contour, you can try to predict this one. The topography you can predict very easily. Okay. So this is the typical example of contour line you can see here. Now also I would like to try to discuss about some important features of the contour as well, that is termed as a contour interval. If you see here, the vertical distance between any two consecutive contours is known as contour interval. What does it mean? The vertical distance between any two consecutive contours is known as contour interval. Let's say for example, here if you see in this geometry 1100, 1200, so this is known as a contour interval, what I have marked here, the vertical distance between two consecutive contours, right? Similarly, we can also have the another one, the horizontal distance between any two consecutive contours, that is your this one, that is termed as a horizontal equivalent. So it's a matter of case whether you are seeing your contour lines in terms of a plan or whether you are seeing it in terms of the actual topography. If you are seeing in terms of the topography, you may find it is as vertical contour interval, and you may try to record it as horizontal equivalent if you are preparing the contour map or contour plan, right? So horizontal equivalent is the horizontal distance between any two consecutive contours, and your contour interval is your vertical distance between any two consecutive contours, right? So that's about your contours. And simply now also I'm going to discuss or touch upon these 2 points. What I have written over here is application of contour map and some of the important characteristics of contour map, right? Look, contour maps are very, very important in fact in your engineering field, because through these contour maps what it will going to get, your contour maps provide valuable information about the topography of the area, whether it is flat area, whether it is undulating area, whether it is mountainous area, whether it is valley, right? So the nature of the ground surface of an area can be understood by studying your contour map. And the applications, if you say, let's say it will going to help you in selecting the sites for different engineering projects such as roads, canals, railways, etc., to find the best possible route of communication between your different places. The capacity of reservoir and the area of submergence can be computed, right, to ascertain the intervisibility of the station. So there are so many applications of the contour map, you can say, but generally they are most of the referred to simply describe the topography of the area, any area you can say, right? So to estimate the quantity of cutting and filling, etc. So these are certain applications you can say of contour map. And in terms of the characteristics of contour, I am not going to discuss every characteristic, but still going to discuss a few important one. The first, since you see the every point of the contour line has the same elevation, contour map with a constant interval portrays the conformation of the ground in characteristics manner, and the knowledge of contour characteristics helps in identifying the natural features of the area from the given map and in avoiding mistakes in plotting the contours correctly. What does it mean? Through these contours, you should be able to identify which form of topography it is indicating. Let's say all the points on a contour line have the same elevation, the first characteristics, right? So it is written like this 1100, and then you can stretch the lines like this. Also, two contour lines do not intersect with each other in any case. That's another characteristics. Third can be the contour lines always form a closed circuits no matter what, but these lines may be within the outside of the limits of the map. That's why you may find it as the open one or not the closed one. So that's why contour line must close itself but cannot end on the plan, because plan may be somewhat limited to the area. But mind well, contour lines always form a closed circuit. Also, contours do not have sharp turning. Similarly, let's say if your contour lines are closer near to the top or of a hill and high ground on the wide apart near to the foot. What does it mean? Let's imagine, let's try to identify the topography from this contour only. Let's your outer contour is of, you can say it's your 1100. As you moving inside of the rings, it is 1200, 1300, 1400. That means your RLs are increasing. What does it mean? It is indicating rise, it is indicating hill. So that's why you see here topography, it is indicating high. If it would have been in reverse order, let's say if your 1400 was is outside, and then you are, as you are moving inside, 13, 1200, 1100, so it is indicating depression, it will indicate your valley part, right? So you should always able to read your topography through this contour map. So these are certain characteristics of contour, you can say, right? So I hope I have touched all important topics of leveling, and now you understand and you have better idea about the leveling, right? Also, as I said, that for better understanding and for more further detailed information, you can refer certain reference books and textbooks as well, right? So try to read this, try to see this video properly, and have some time in watching this video, and try to use certain form, try to record the things as many as possible during watching this video, so that it will help you in understanding concepts in very proper way, right? So thank you very much for watching this video. Thank you.